When we talk about the cardiovascular system, we're concerned with blood flow, and we need to make sure that blood flow is sufficient to maintain the composition of the fluid that surrounds cells. Blood pressure pushes fluid through the vessels, and the vessels have resistance that slows down the blood flow. So if we want to look at blood flow, we have to look at the relationship between pressure and resistance. Today we're going to look then at three relationships. First, the fact that blood flow increases as pressure increases and slows down as the resistance of the vessels increases. The resistance of the vessels is determined primarily by the radius of those vessels. The way resistance changes in those vessels is through increasing or decreasing the radius of the vessels. And lastly, we're just going to rearrange the first relationship to look at blood pressure and the fact that blood pressure increases if cardiac output increases, and blood pressure increases if resistance increases. I should be using proportional to rather than equal to for these relationships, but since we're not doing precise calculations, we're just going to let it slide. This might make a little more sense. Okay. So starting with the first relationship, blood flow increases as pressure increases. For my system here, I'm going to have a blood vessel, which is a straw. And for a pump, I'm going to use my lungs. And we'll see that if I increase the pressure pushing fluid through the straw, the flow rate increases. About 3 seconds. Now I'm going to blow harder. Okay, in about 2.5 seconds. Not particularly profound there. If I blow harder, the water flows faster. More pressure, greater flow. What about resistance? The way I'm going to change resistance in the system is by using a larger diameter tube. If pressure pushes fluid through the vessel, resistance is a force that opposes that motion. So it's basically pushing the other way. So it makes sense I can get more fluid through the straw either by increasing pressure or decreasing resistance. The way we can do that is by increasing the diameter of the vessel or increasing the radius of the vessel. So with this straw, the internal diameter is about 3 millimeters. In this tube, the internal diameter is about 6. It's a longer tube, which would typically have more resistance, but because the radius is so much larger, the resistance is going to be lower. So let's have a look at this. About 1.3 seconds. So the larger diameter tube had a much lower resistance even though it was longer. In fact, because the diameter was about twice as big as the first tube, the resistance was 1/16. Now the actual resistance was greater because of the longer tube, and the numbers don't work out precisely because it's a very imprecise demonstration. But nonetheless, you can see that the resistance in a larger diameter tube is much lower. So far, we've been talking about pressure, flow, and resistance in a single vessel. But in an A&P class, we're often interested in what's going on in the entire body. So pressure at the beginning of the vessels, of all the vessels, is really the blood pressure. The resistance in the whole system is called total peripheral resistance, or TPR. And flow through the whole system is cardiac output. So we can look at this relationship and we find that blood pressure is equal to cardiac output times total peripheral resistance. How do we get there? Well, we already know that flow is equal to change in pressure over resistance in a single vessel. We can just use a little substitution for our system. So cardiac output is the flow through the system. Blood pressure is a change in pressure, and resistance is the resistance of all the vessels added together. If we multiply both sides of the equation by total peripheral resistance, abbreviated TPR, we come up with BP, or blood pressure, is equal to cardiac output times total peripheral resistance. So how is blood pressure increased in the arterial side of our circulation? Two ways. We can increase cardiac output or increase resistance. Increased cardiac output would be a function of the autonomic nervous system and partially the endocrine system. And resistance changes as the diameter of the blood vessels changes. And remember, a small change in diameter leads to a large change in resistance because the resistance of any vessel changes inversely to the fourth power of that radius, or basically if we have the diameter of a vessel, we've increased the resistance by 16 times.